today I will discuss the set and relation sets. A sets, a group of distinct items. For example, A, dog, cat, birds, and then B, apple and mango. So basic operation, union, A union B. All elements from both sets, for example, dog, cats, union, cats and bird equals dog, cat, and birds. So next is intersection. Only elements that appears in both sets, for example, dog, cats and birds for equal is cat. So next is complement. Elements that not in the sets but in the universal set. So for example, if U is equal to 1, 2, 3, 4, 5 and A is 1, 2, 3, then A is equal to 2, 4, 5. Next is relations. Relations connects between elements of two sets. So for example, students equals Anna and Ben. Subjective equals math and English. So in relations, Anna and math and Ben in English. So in IT, relations are like a table in databases or connection in networks. So number 2 is propositional logic. Propositional logic is a statement that can be true or false. So for example, it is sunny. It could be true or false. So the second one is to go to school, not a propositional. So the third one is logical connectives, not or P. If P is it is sunny, then negative P is it is not sunny. Second is N or PQ. I have money and I have time. Both must be true. So the third one is, for example, I will play basketball or football. At least one is true. So the fourth one, if then. PQ, for example, if it's rain, then I'll bring umbrella. So next is if and only if. You pass the exam if you study. So that's the example. So in IT, use if it else statement, logic gates, and binary code. Today I will be talking about the proofs and techniques. So first one is the root proof. Show step by step that a statement is true. For example, if a number is even, then it can be written as 2k multiply still then. So the next one is contrapositive. Prove if P contrapositive Q by showing if it's not Q contrapositive is not P. So for example, if a number squared is odd, then the number itself is odd. The next one is contradiction. Assumes that opposite finds an impossible result. So for example, assume 5 is even leads to a nonsense. So 5 is an odd number. So the next one is induction. Step 1, prove for n equals 1. Step 2, assume true for n equals key, then the proof for n is equals to k plus 1. So for example, 1 plus 2 plus whatever number plus n equals to n plus 1 equals to 2. So in IT, proofs are used to check algorithm to system correctness and security. So the fourth one is counting principles. Addition rules or rule. So if you can do, so for example, if you can do task A in 3 ways or task B in 2 ways, total is 3 plus 2 equals 5. So for example, choosing tea in 3 types of tea or coffee with 2 types of coffee. So that's the 5 choices. So multiplication rules and add rules. If you can do task A in 3 ways and task B in 2 ways, the total of 3 times 2 equals 6. So for example, 3 shirts times 2 pants equals to 6 outfits. So factorial, way to arrange n items. So for example, 3 equals to 3x, 3 times 2 times 1 equals 6. So arrangement of A, B, and C. So the next one is for pronunciation or order matters, choosing arranging items. So for example, arranging 2 letters from A, B, C to A, B, A, C, B, A, B, C, and C, A, and C, B. So that's at 6 ways. So the next one is combination or order doesn't matter, choosing items without order. So for example, choosing 2 fruits from apple, mango, orange to apple, mango, apple, orange, and mango, orange. So in IT used in cryptography or password algorithm, networking, and database wires. So overall, in summary, sets and relation organize data and show connection. So the next one is propositional logic. It helps in reasoning, coding, and circuits. So next one is proofs and techniques, ensure the correctness of math statement or algorithm and system. Counting and principles, tools to calculate possible outcomes and arrangements. The next one, and these are the building of blocks of the discrete mathematics, which is the foundation of IT programming and security and algorithms. Thank you. Today I'll be talking about the universal quantifier, which uses this symbol. In a simple word, this symbol means for all or for every. It is used in mathematics and logic to say that something is true for every element in a group or domains. So, universal quantifiers, this symbol means for all or for everyone, for every. We use it in math and logic to say what something is true or in every element in a group, which is domains. For example, in these slides, this means for all x is greater than 0. So in a simple word, every number is greater than 0, but this is not true if we include negative numbers or 0. So the statement depends on the domain or the set of numbers we are talking about. For simple example 1, which is true statement. For all x plus 0 equal x. So for all x, adding 0 does not change the number, so which is always true. And for example 2, which is false statement. For all x, the x squared is greater than x, so this is not true. And this one, if x is equal to 1 or x squared equals to 1 and not greater, means it's not true. And for example 3, in a daily life, for all person, which means person needs air to live. So every person needs air, so which is true. So in a summary, the universal quantifier means for all. It tells us the statement applies to every element in the group. For example, for all x plus 0 which equals x means adding 0 to any number gives back the same number. It's always true. But if for all x is greater than 0 is not true. If we allow negative number, we use for all to make a statement about whole group of things in a short. So today I will explain the concept of intersection of sets. So the intersection of sets is the sets that contains all the elements that are common to two or more sets. In other words, it shows that the set shares. Whenever we want to find intersection, we look for elements that appear in all sets involved. We use the symbol N to represent the intersection. For example, if we have two sets A and B, their intersection is written as an A intersection B, and it's include all the elements that are belong in both sets A and B. Let me give you a concrete example. Suppose we have two sets, set A 1 2 3 4 and set B 3 4 5 6. To find the intersection, we have to look for a number that appears both sets. In this case, the number 3 and 4 are the both A and B are the both set A and B. So the intersection could be A intersection B equals 3 and 4. We also imagine this using Venn diagram. If we draw two overlapping circle for A and B, the area where circle overlap represents the intersection, which again contains number 3 and 4. So, in summary, the intersection of sets is all about finding common elements. It's very useful concept in mathematics, and every situation where we need identify shares items or characteristics between groups. So today, I will explain what's an injective function, also called as one-to-one function. And it means a function is injective if different inputs always give different outputs. In simple words, no two different values from the domain can share the same result in the codomain. So let's give an example. Suppose you have the function. So if fx is equals to 2x plus 3, we have just to change the value of x. So if we put x equals to 1, the result will be 5. And also if we put x equals to 2, then the result will be 7. And another one, if we put x is equal to 3, the result will be 9. So the pattern is simple. Every time we increase x by 1, the result increased by 2 because of the 2x part. And another example is if fx is equal to x squared, but only if we have take the positive number as an input. So if x is equal to 2, then f2 is equal to 4. Also, if x is 3 equals to 3, then f3 is equals to 9. As we can see, every input gives us a unique output or result. That's why this function is injective. Now let's connect this in real life situation. Imagine a student in a school. Each student gives a unique student ID number. So no two students can share the same ID. This is exactly like an injective function. Every person maps to only one unique output. Another example is if a person and their cell phone number, each person has their own phone number, and no two people can share the exact same number. That's the another way to understand an injective function. So this shows that injective functions are important because they keep things organized and unique, making sure two inputs are connected in the same output. So, an injective function is a type of mathematics function where each element of the domain, the sets of input values, it's mapped to a unique element of the codomain, the sets of possible output values. So, in other words, an injective function ensures that no two different input produce the same output. So that's all for my report.